we kind of wind up Unit 1 talking more about working problems using what we call ratios or factor label method of working problems. And I kind of promised that this is actually here to stay throughout the rest of Introduction to General Chemistry. The other thing is, honestly, this way of working problems can really help you working other physical science problems or maybe just other problems. So we need to hit a couple of things. I'm going to kind of take it up notch, and we're going to talk about actually squared and then cubed length units. And then I want to finish up by looking again at density. We talked about how you can calculate the density of an object by taking its mass and its volume and dividing it out. But we're going to actually use that property as a conversion factor to work problems. And similarly, we're going to use mass percent as a conversion factor. So here we go. Here's a question for you. I don't guess it's necessarily a question, but you know within the English system, 1 yard is exactly equal to 3 feet by definition. So on the next slide, I'm going to show you actually 1 yard by 1 yard, 1 square yard, and each yard is 3 feet. I didn't do that very good. Okay, so how many square feet are in 1 square yard? And it looks like this. So the way this is we have along each edge we have 1 yard, and of course 1 yard is equal to 3 feet. So here's 1 foot, 2 foot, 3 feet. So each of these squares is what? A square foot. Okay, so how many square feet are in 1 square yard? There are actually 9. And I know there's 9 because I can count these boxes. And I also know there's 9 because I looked ahead in the notes. And we'll actually work, the problem we're working here is if you have 1 yard squared, like somebody told me, or us, how many question mark feet squared is that? And we're going to use that using the factor label method. So we could, one way, and this isn't necessarily the factor label method, but does this make sense? We had 1 yard times 1 yard to get area. Okay, well, 1 yard is 3 feet, so we could take 3 feet times 3 feet to get the same area. And what is 3 times 3? Of course, that's 9. And what is feet times feet? That actually is feet raised to the second power. So if we kind of think of it out this way, voila, we have the right answer. Okay, that's actually what we saw. A square that is 1 yard on both sides. If you get to get the area, you multiply those, and you get 1 square yard is equal to 9 square feet. So let's go ahead and use this working the factor label method. Now the thing we want to convert is the 1 yard squared, so I put that over 1. And then I'm going to use actually an equivalency statement. I know I want to go from 1 yard squared, I want to go to feet squared, question mark feet squared. And I know that 1 yard is exactly equal to 3 feet. So I'm going to go ahead and I'm going to use that to my advantage. So my next term is going to be 1 yard over 3 feet. Now, if I were to stop right there, okay, yards would cancel. Actually, only one of these yards up here would cancel. I would cancel 1 and leave 1. So I'm fine then if I want to introduce one more term of 3 feet over 1 yard. If I introduce 2 terms, then check this out. Now my second yard cancels, and I'm left with units of feet times each other, which is what? Feet squared. Take the numbers times each other and you end up with 9. Okay, that's kind of how we work that problem. There's the middle term. Okay, but we have to actually have 2 of those terms because we need units of yards squared in the numerator. We need to cancel in the denominator. Okay, so this actually then is, we've officially worked this problem of converting 1 yard squared to feet squared using the factor label approach. The only thing that was different was we had to use 2 terms, okay, of that equivalency statement, 2 ratios. I had to use it twice in order to get our yards squared to cancel, and that left with us feet squared. Well, if you look at the previous slide, if we were to take that second and third term, which is what, 3 feet over 1 yard, if it's multiplied by itself, okay, we could say that it's raised to the second power, and that is fine. My fear here is that we need to make sure that this square goes for the number and the unit. That square goes for the number and the unit. In other words, if I were to expand this out, that little ratio I have here is equal to what? 9 feet squared over 1 yard squared. All right? Very good.